All right. Let me go like this so I know who's talking and I can monitor the chat. All right, greetings, scholars. So beautiful mind here. So we're gonna go ahead. So today, let me see. So we're past the halfway mark. Just a quick recap on how I calculated the midterm. The midterm, it doesn't really hold any weight or value. It's just a snapshot of where we are at the halfway mark, right? So we're at the top of week 9 for this class. The way I calculated midterm, I think your grade might be a little bit higher than what's showing. So I think for you all, I did factor in like Alex. Then it dawned on me, I was like, wait a minute, they don't have to do Alex. So your grade might be a little bit higher. But again, midterm grade does not go on. It doesn't go on record anywhere. It's just to kind of give you some feedback so you know where you are at the halfway mark. So I think again for this class, most people's midterm grades are actually slightly higher because I did erroneously include Alex into you all's, and it's only like 10%, so it's not that much higher. But I'll make sure that the one that matters, which is your final grade, that I do not include Alex for you guys. So going forward for right now, for the end of the day, I think we go from 225 until it's always what 305 or 315. I always forget. I think it's 315 for you guys. So we're just gonna try to power through. We need to get through to about slide 12. Actually, it shouldn't take that long. We should be able to hit our mark. I can't think of anything else. So I think I'm gonna just go as far as I can today. Just try to maximize the time so we have less that we have to do on Thursday. Um, yeah, I can't think of anything else. Again, if you have any questions, comments, or concerns, feel free to type it into the chat. I am monitoring the chat, and we can work it that way. So let me change this view to this, and let's rock and roll. Also, if you are of the age, check. Like I actually was able to vote yesterday, right? So yeah, I think I voted yesterday. So if you can vote, go ahead and vote. If you can, that would be greatly appreciated. Okay, so we have so we're moving into chapter 2 with polynomial and rational functions. Okay, and so we're gonna start with section 2.1 quadratic functions. I think I have it there. Someplace I don't have it. It's fine. So we're looking at section 2.1 quadratic functions. The grade should be on Banner Web. That's midterm grade. Again, that's just a snapshot of where we were at that moment in time. Yeah, not in Blackboard, on Banner Web. So if you go back to the portal and those apps, one of them says is Banner Web. That's where you can find your midterm grade. So some of the objectives here, we want to look at graphing a quadratic function in standard form, graphing any quadratic function, and solving problems modeled by quadratic functions. Okay. So a function of this form that you see on the screen here, where a, b, and c are real numbers, where a is not 0, is called a quadratic function. All right. So notice the highest exponent on the variable is 2. The leading coefficient is not 0. We call this a quadratic function. So a quadratic function of this form is said to be in standard form. Right. So the graph of this function is a parabola with the vertex being h comma k. And the parabola is symmetric with respect to the line x equals h, right, which is called the axis of the parabola. If our a, which is our leading coefficient, if our leading coefficient is positive, then the parabola opens upward. If our leading coefficient is negative, then the parabola opens downward. Okay, and we're referring to this a here. Okay. If we have questions, just type in the chat and I'll address them as they arise in the chat. So with this example, we're asked to find here. Actually, let's do it like this. Let's go seamless. We want to go. Oh, I don't have my page. Oh, that sucks. Okay. So let me go ahead and create it then. Yeah, add a page. I'm going to take a copy of this. That's trash. Okay. Goes right here. And one other thing. Paper, graphic. Okay. So here we're asked to find the standard form of a quadratic function whose graph has this vertex and passes through this point, right? So again, if you have a formula sheet, this is a good formula to add to your formula sheet. You don't necessarily have to commit this to memory. I really just want to. I just want you to be able to use it properly, right? So the standard formula for quadratic is going to be. Let me see. How can we get this to work better? F of x equals a. Hang on. Let me see if I do this. This usually helps. I might have to turn that fan back on. Maybe I'll try my personal fan. Maybe that'll work a little bit better. I'm giving my pen like a moment or two to charge. It's kind of acting up a little bit. Yeah, he definitely already got attendance for today. Oops. Okay. All right, let's see if that did it. Hopefully, allows it to behave properly. Oops. All right. So now let's try this. So now the standard form of a quadratic is going to be a times x minus h squared plus k, right? So it says the vertex is negative 3, 4, so that means our given, so that means our h comma k is going to be negative 3 comma 4, and it says passes through the point negative 4 comma 7. Oops. So we want that to be, that's going to go in as our x comma y. Again, it's going to be negative 4 comma 7. Okay. Can you guys hear me okay? Is there too much like background noise? I think I can maybe move this over here. It might be a little bit better in the background noise. Okay. So again, we're given the vertex and a point that the parabola passes through, right? So we're just going to plug in what we have into our formula. So let's see. So this is going to be our h, this is our k, this is our x, this is our y. Okay. So if we plug in what we have, we don't have anything for a. Now our x is going to be negative 4. Our h is going to be negative 3. Notice my use of parentheses. Notice how I'm using my parentheses. And my k is going to be 4. And my y is going to be 7. Okay? So I'm going to, I go into some other details with my other students. I would check my YouTube and watch the videos that I did with my students from yesterday. I go into some other details at this point that I'm not going to do now just because of our time constraint. But if you want to see those details, you can even like just kind of scan through the video and you'll see some things that are a little bit different from these examples. As far as the presentation with you all, I'm going to do this a little bit faster, just as far as the sake of time. Okay, so if we focus here within the parentheses, right, we got this double negative going on. So double negative becomes positive. Negative 4 plus 3 ends up being a negative 1. So the a comes down. This ends up being a negative 1 squared plus 4 equals 7. Again, we have one equation, one unknown we can solve. Okay. 1 squared is 1, so then that becomes a plus 4 equals 7. Subtract 4 on both sides, a equals 3. Okay? So we have that what? A is 3. Our h was negative 3. And our k is 4. So if we plug those into our formula, that means we're going to have f of x equals a times x minus h squared plus our k. We got to do one more step to simplify. We're going to get f of x equals 3 times x plus 3 squared plus 4. Okay. Now we could check and make sure like like we could plot those 2 points and then graph this quadratic. Again, I'm going to have to defer you to my videos with my other students to see some of those details. And I want to say that each video is different. Like I did different techniques in both videos. So I would watch them both to get a more complete, thorough set of content knowledge, okay? But for the sake of time, I'm going to go with this. Let me see who's coming in late. Is this for my next class? I don't know who AJ is. Send me a message. Let's see, how did you get A? Or is that explained in the other video? Now, we actually did it here. We just solved for A, all right? So if we go back to the formula for the standard form of a quadratic, the blue formula that you see at the top of the screen right now, we plugged in everything that we had, right? So we had that H was -3, you see it here. K was 4, you see it here. X was -4, you see it here. And Y was 7, you see it here, right? So the only variable we didn't have from here was A. Yeah, I don't know who that is. And then what time is it? Class starts. That was kind of late. Give me a moment. Let's go here. Let's do. Oh, actually, you know what I can do? I can leave that open, and I can actually do it here, and it won't show. Awesome sauce. That actually helps out a lot. I still don't know who AJ is. Like he's gonna have to give me more information. Oh, I think I know who it is. Let me see if I can message him. All right, so if they respond, if they tell me their name, I'll let them in. Oh, didn't mean to close that. Let's open it back up and shrink it down to size. Okay. I just learned a new trick when people come in late, how to not disrupt everything so much. Come on. Don't worry about it. Okay. And let me just suppress that. Okay, hopefully that answered your question about where A came from. We plugged in everything we had. The only thing we didn't have was A, and then we solved, and we were able to solve for A. So then we plugged in our A, H, and K, and that's how we got the formula. Okay, and then let's look at the typed up result. Okay. So again, all these notes, anything that you see that's typed, you actually already have access to it. It's on our Blackboard page. It's on our Blackboard page. You can pull them up. And the recommendation is to go through the notes as best you can before class, right? So then that way, idealistically, when I go to present it in class, you want that to be a review. Even if you can get ahead on the homework, that'll totally serve you. Like I want to say, most of the homework is available. Just do your best to get ahead, and we'll work at that. Okay, but I think we got the same thing. 3 times x plus 3 squared plus 4. Okay. So this example is on graphing a quadratic function in standard form. We're actually sketch the graph of this quadratic. We have f of x equals this. Okay. So what I'm going to do, I'm going to create some space for myself. I'm going to add a page, and I want to get a copy of this. And actually, let me go view, seamless, and I want to get a copy. I don't need that one. Okay. So let's take some time and sketch this graph. Okay. All right. So we're asked to sketch the graph of this parabola, right? So in this form, automatically it gives us the coordinates of the vertex. Our vertex, again, this is in the form a times x minus h plus k. The h comma k is our vertex. You should notice a change, though. There's one little change you have to kind of be cognizant of. So the x coordinate of vertex is going to be from here, and that means it's going to be -2. You do have to kind of flip the signs for the x coordinate. Then the y coordinate is going to be 12. Okay, so that's going to be our vertex. We see that the a is negative. Sorry, a is negative. So that means the parabola opens downward, right? And so because we have the vertex, okay, was he not? He can't. Can you get him to fix his name so that way in the future I won't? Because if I don't know who he is, I'm not gonna let him in. Let me see. Okay, yeah. Wait a minute. Today's present, right? How do I? Hang on. Come on. Okay, here it is. There we go. Okay, that looked like it worked. And then let's do like this. Okay, he should be joining. Hopefully, let me see. It seems like it's still okay. Okay, so let's graph this, right? We have the vertex. So here, let me see. X and Y, and it opens down. Okay, so we're gonna make a quick graph paper. So this is gonna be the positive X, and positive X is gonna go in this direction. Then we're gonna have a positive Y goes in this direction. Okay, let me see. 2, 3, 4, 5, 6, 7. 7 is fine. Let me copy these guys. Paste. Okay. All right. So we got our graph paper. So now, looking at this formula, again, the vertex is going to be -2, 12. So I'm going to plot that point. And let me label this. So here's the origin. This is going 1, 2, 3, 4. And actually, let me change the view, not the view, but the paper to like this. I think this might be a little bit easier. 1, 2, 3, 4, 5, 6, 7. Let me see. 1, 2, 3, 4, 5, 6. These are all negative. 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Oh shoot, that's not high enough. I'm gonna have to do these by 2s instead of by 1s. So the x-axis is fine, but for the y-axis, I'm going to go 2, 4, 2, 4, 6, 8, 10, 12, 14, 16. Okay, that should be fine. Okay. So now let's plot the point negative 2, 12. So if we go left 2 and up 12, the 2 is here, the 12 is there. So we have this point here. All right. So then now so now that we have the vertex, if these are the coordinates of the vertex, then now we can identify our axis of symmetry. Style. Okay. So we have an axis of symmetry, right? So what this means is that whenever we get a point on the left side, we also get a point on the right side, right? So if the axis of symmetry is x equals -2, let's calculate when x is equal to -1. And just as a showcase, I'm going to use my graphing calculator. So let me pull up the graphing calculator and let's do a demo, crunching some numbers in the calculator. Reload, refresh, looking good. And we're going to drop you over here. Okay. So let's do a demo. So say I want to crunch some numbers in the graphing calculator. This is just one technique. I'm going to go to my y equals in the upper left hand corner. I'm going to type -3 parentheses x plus 2 close parentheses squared plus 12. Quit. Then I'm going to go. Now, if you see the clear button here, to the left of the clear button is a button that says VARS. I think that's short for variables. I'm going to go to the right to go to Y variables. I'm going to click number 1 for function and number 1 again to call that function I just typed in. So now I want to do, like, for instance, we can check really quickly. When x is -2, the answer should be 12. So then I want to go ahead and do when x is -1, right? If x is -1, we get 9, right? So we have another point, -1, 9 is here. But if we go 1 to the right, we're at 9. That means also if we go 1 to the left, we're also at 9. Whenever we get a point on the right, we also get a point on the left and vice versa. When x is 0, I'm just going to plug it in. So I'm going to recall and let x be 0. Oops, that's not a 0. Okay, so when x is 0, it looks like y is 0. Let me see. 4 times 3, 12. Okay. So we have, so if we go 2 to the right of the axis, we're at 0. That means if we go 2 to the left, we're also at 0. Let me see when x is 1. Just because. -15 is way off of our chart, right? So to graph this, I know I got to go off the chart before there. Let me see. I want it to be, what x value gives me -5? That's going to be too much. Okay, so to graph it, something like this. And I'm just going to snap it. If it snaps, come on. I'm tripping. Try this one more time. Okay. So we're going to put you about there. Put you about here is good. And then can we get you to go there? Oh, so close. So we're going to put you about there. You go about here. Now let's try this one. Still a little off. Sorry. I'm just being a little bit. Okay, that's pretty good. That works for me. All right. So we have a graph. And then let's do like this. Undo. That's not right. There it is. That looks good. And can I just, sorry, I'm just being a little bit OCD. Yeah, copy. And I just want to paste. And I want you to work over here. Okay. All right, that was fun. So again, we used the vertex. Then once we had the vertex, it created the axis of symmetry for us. Then whenever we found a point on one side, we automatically got a point on the other side. And then so it's all they all were like 2 for 1, right? We got a whole bunch of 2 for 1, twofers, right? 2 points for the price of 1. Okay. I want to keep you for no more than 10 more minutes. Let's go for another 10. Right. Let's go to View, Single Page. We're doing pretty good. We're pretty much where we need to be. And let me go ahead and do like this to go to Paper and turn off the lines. Okay. That's more than enough. I mean, we can actually graph it in our graphing calculator, but this is more than enough. Parabola opens down. I think we found those values. And I think we got the same graph or a similar graph. Okay. So we have a computer generated and we did it by hand. Let's see, sketch the graph. Okay. Identify A, B, and C. Let me see what route are they taking here. Okay, so they're using the vertex formula. Okay. Yeah, this will be the last one. So let's do one more. Let me go ahead and add a page. And change the view to seamless. Sketch the graph. So let's get a copy. I don't need that one. And this one. So we're actually sketch the graph of this parabola. We're going to do another example. Okay, this is a little bit different, but it's very similar. Similar notion. So one thing a little bit different I did with my other students, I went on to introduce this notion or idea of what we have what's called the vertex formula. I introduced it a little bit early for them. We had more time, so I was just kind of filling. Let's go to Paper like this. Okay. So I'm going to use the vertex formula. The last one, because the last example was in standard form, we were able to see the vertex fairly quickly. But in this one, it's not so obvious as to what the vertex is. Now we could do completing a square to put this in a standard form, but I'm just going to jump straight to the vertex. If we're going to graph this, I'm just going to jump straight to the vertex. Now the vertex formula, the x coordinate of the vertex, which is going to be our h, is going to be negative b over 2a, right? When we go to find the y coordinate of the vertex, which is our k, that's basically going to be f of h. Whatever answer we get, we're going to pass it through the function, okay? So again, let's go ahead and find the x coordinate of a vertex, which is h, which is going to be negative b over 2a, okay? So now from the original, it says that our a is 2, our b is 8, and our c is negative 10, okay? So then if we plug these into our formula for our vertex formula, and let me label this as the vertex formula. Okay. So if we plug these into the vertex formula, it's going to be negative, our b is 8 over 2 times our a is 2. So 8 divided by 4 is negative 2. So the x coordinate of the vertex should be negative 2. So then if we want to find the y coordinate of the vertex, which is going to be our k, we're just going to do f of that answer. In this case, it's going to be f of negative 2. So that's going to be 2x squared plus 8x minus 10. Notice how I handled my x's. I did a blank set of parentheses for each x. And then what number goes into each blank parentheses? This negative 2, this blue negative 2, right? So this becomes negative 2, this becomes negative 2. We just replace each x with a negative 2 inside a set of parentheses. So the parentheses help us to keep track of the signs. Like for instance, in that first one, if we didn't use the parentheses, we might be tempted to do 2 minus 2 to get 0, which would be totally wrong, right? So negative 2 squared is a positive 4. 4 times 2 is 8. 8 times negative 2 is negative 16 minus 10. So that's going to be a negative 2. Looks like it's going to be negative 18. Okay. So then the coordinates of the vertex. So the vertex should occur at, what is that? Negative 2, negative 18. Okay. Let me add a page. I see the time. I'm just trying to wrap this up and get you all out of here. So back 2 and down 18, which way does the parabola open? The parabola opens upward because the leading coefficient is positive. So we need to do something like the following. We got this. Okay. Then we can go like, kind of like this. Okay. Let me undo that. Positive y goes in this direction. Okay. This is the positive y. This is the positive x. Let's move this to center it a little bit better. I think that's okay. Let's see. We need to get to negative 18. 1, 2, 3, 4, 5, 6. 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Okay. So this is our origin. This is going by 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. These are negative. This is going by 2, 4. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. These are negative. Okay. Let's see. Oh, first we plot in the vertex, right? Negative 2, negative 18. So let me do it like this. Paper, kind of like this. So then negative 2 is here. Negative 18 is here. So here, this should be the vertex. Again, this identifies our axis of symmetry. So we can use that to graph. Style, about that thickness. And I usually like to do this one. That's fine. And then whenever we get a point on the left, we get a point on the right. Let me see what's simple. So the easy point to test would be when x is 0, y is negative 10. So when x is 0, y is negative 10. So if we go 2 to the right, we're at negative 10. 1, 2 to the left, we're also at negative 10. Maybe we can find the intercepts. I'm just going to, I kind of want to be a little bit quick. Let me see when x is 1. So when x is 1, that's going to be 2 plus 8 is 10. Minus 10 looks like a 0. Okay? So when x is 1, y is 0. So we're going to plot that point. And so if we go 3 to the right, we're at 0. That means if we go 3 to the left, 1, 2, 3, we're also at 0. Let me just do one more. 2 should go off the chart. That's going to be what? 2 squared is 4 times 2 is 8. Plus 16 is 24. Minus 10 is 12. It goes off of our chart. So I just need to go off the chart before we get to the 2. So I'm going to do something like this. The graph should be something sort of like this. Okay. Let me see. That one's there. Just going to do like this for now. That one's about there. Okay, we got to do a little bit better. About to let everybody go. I see the time. That's good enough. Almost. Okay, that works. Okay. That's probably my next, whoever it is. I thought I let them in. They must have like came and went. Okay. So let me wrap this up. I just want to do like this, draw some arrows. That goes about there. That goes like, come on. That's good. Okay. And then let me draw this one. Okay, the arrows just mean basically continue the pattern in that direction. That's pretty good. Okay. Let me go like this for paper. Turn this off. Okay, so we did it by hand. We got something like this. And just to kind of match what they did. There it is. 1, 0, negative 5, 0. You see it there. Okay. If there aren't any burning questions, I'll see you guys on Thursday. I'll be around for a few minutes if anybody would like to ask any questions. Otherwise, you guys are great. Just keep up with your work on Pearson. Don't worry if I said anything about Alex, you guys do not have to do Alex. All right, that's my other classes. So just mainly just do your work on Pearson and just check in each day. Those are the main things I'm looking for. All right, guys. You guys are awesome. I'll see you on Thursday.
See you Thursday.
Yep.
Thank you.
Yep. Okay. Okay. So let me see. Make a note. We're gonna say how many? Oh, we're almost done. Stop here. Tuesday. What's today's date? Tuesday, October 13th. Then we're gonna say start here Thursday, October 15th. Right. Okay. I guess we can go ahead and stop the stream.